The entire movie? Shh. We'll learn a lot from the old movie.
It goes for a whole 1 minute 50. But here is...
Sad face.
How many of you, put up your hand if you've actually seen The Wizard of Oz before? Good, okay. So, this is the scene where they meet the wizard. And my answer for why you should learn algebra is so you can meet the wizard. And I'll explain that after you've watched this little clip.
That makes no sense.
It doesn't make sense yet, but I hope it'll make sense in a minute.
Please, sir, we've done what you told us. We brought you the broomstick of the Wicked Witch of the West. We melted her.
Ah, you liquidated her, eh? Very resourceful.
Yes, sir. So we'd like you to keep your promise to us, if you please, sir.
Not so fast! Not so fast! I'll have to give the matter a little thought. Go away and come back tomorrow.
Tomorrow? Oh, but I want to go home now.
You've had plenty of time already.
Yeah. Do not arouse the wrath of the great and powerful Oz. I said come back tomorrow.
If you were really great and powerful, you'd keep your promises.
Do you presume to criticize the great Oz? You ungrateful creatures think yourselves lucky that I'm giving you audience tomorrow instead of 20 years from now. Oh, the great Oz has spoken. Oh, pay no attention to that man behind the curtain. The great Oz has spoken.
Who are you?
Oh, I am the great and powerful Wizard of Oz.
You are? I don't believe you.
No, I'm afraid it's true. There's no other wizard except me. You humbug! Yes, it's exactly so. I'm a humbug.
Oh, you're a very bad man.
Oh, no, my dear. I'm a very good man. I'm just a very bad wizard.
Was that?
So, I know I had some explaining to do, because how does that relate to algebra? Well, doesn't really, but more and more these days, there are things we don't entirely understand. We use them every day, but we don't entirely get how they work, be it computers, Google searches, traffic lights. And one day, you might want to figure out how they work, learn a bit about what's behind them, so they aren't as big and scary and unknowable as the wizard. You might want to pull back the curtain. And the key to pulling back that curtain is algebra. And that's why you should learn it. And I'm not saying you'll use it every day in the future of your life, but one day you might want to just take a peek behind the curtain and figure out why something works the way it does. Why do the traffic lights always seem to be against you? Why does Google search know exactly what you want, which is kind of scary? Why does Facebook suggest friends that you've never met before, but apparently they're friends because you've got lots of friends in common? All of those things can be explained through algebra, and that's why we're learning it. And yes, I know at the moment what we're doing now doesn't immediately help you, but it's a bit like learning to bang a nail into a piece of wood. You've all hammered nails into wood before.
No.
Let's face it, nailing one nail into a piece of wood doesn't actually help you a huge amount. That is not building a house or a cubby house. But you have to learn how to do that before you can bang two pieces of wood together. Then you start doing other things, sawing. Soon you make those little bird houses there and put some trees, little toolbox for dad or something, and you get more and more and better. You guys are at the algebraic stage of hammering one piece of nail into one piece of wood. And you are learning that more and more so you can see behind the curtain. Make some sense?
No.
Right, well I tried. Bodhi, you have a question?
I know how traffic works.
You do?
Traffic lights work.
How do they work?
Yeah, there's sensors, but if there's no cars there, it's on time schedule, but if there's no cars over the sensors, they just keep waiting for that.
Good. And did you know the time schedules change depending on the time of day?
Yes.
Yeah? So if it's rush hour in one way and lots of cars are going one way, the traffic lights will automatically adjust for that direction. And same in the opposite way.
To get to work.
Yep, so to get to work and to get back from work.
That's why the traffic lights when we go to school are always against us.
Modern Wizard.
Alright, so that Wizard of Oz, yes, was filmed sometime in the 30s and since then has been coloured in digitally. So yeah, it's in a way the modern Wizard of Oz. Just not the one you've seen, right?
Let's watch the black and white kind.
That was the black and white kind, it just been coloured in.
I know.
Alright, so I realise some of you will have had trouble with the homework because I didn't give you much time to practice in class. What we're going to do today is go through a couple of the homework questions and then I'll let you continue through. No, I won't let you do them on the whiteboards. Can you take out your workbooks where you did the homework, and if you did it successfully, can you follow them through with me and mark it? Mark your own homework. We'll just do 2 of the questions. If you haven't done it, please copy it down as an example. So when you go home tonight, you'll be able to do it. If you did them in your workbook, go to your workbook. Oh, okay. Did you do question 1?
Yeah.
Alright, good.
You didn't do question 2.
Huh?
You said green, question 1 and 2. The green said only question 1, column 2.
3, 1 and 2.
Yeah, but it said only column 2.
Of question 1 and column 2 of question 2.
What have you done?
There's no question 2 here.
Well, I'm just giving 2 as an example.
Oh, okay, fine then. I thought you meant
Alright.
do that one.
So, if we look at 2Q, the question is 7F plus 8FG minus 4F minus 6FG. Now, as you go through these, your first step is to simplify by collecting the like terms, and then only after you simplify do you substitute the numbers in. So the first step is really to identify which one are like terms, and you're welcome to do this with colours if you want. So what if we see F? What is similar to 7F? Yep. Hannah? Oh, sorry, Niantic? Yes, both. You got it right. 4F. But is it just 4F?
Yeah.
I'd say it's minus 4F.
Oh, yeah.
Remember, the sign has to come as well. Alright, and what about 8FG?
8FG take 6FG.
Good. Minus 6FG. The sign comes too. Alright, let's do the yellow first. If we have plus 7F minus 4F, it's similar to saying 7 minus 4. 3?
3.
Good. 3F. Now, 8FG minus 6FG. 2. 8 minus 6 is 2, so it's positive 2FG. Alright. And now we can start substituting the numbers in. So we know that F is 4 and G is 2. So instead of reading it as 3 times F, it is now read as 3 times 4 plus 2 times 4 times 2. Now the reason that it's 4 and 2 is because that's the F and G, and F is 4, G is 2. And this 2 comes from there. Make sense? Alright, so what's 3 times 4? Because we do the multiplications first. 3 times 4 is 12. Now 2 times 4 is 8. 8 times 2 is 16. The sign stays in the middle, so it's plus 16. And that equals 12 plus 16 is 28. Yeah? Know how to do it? Now the next one I believe was part of your homework set, so we'll see how you went. Alright, so our first step, look at the first term. Does it have anything in common with it?
Yes.
Which is common?
2.
Negative 2i. 2ij. Alright, now take the next term.
Plus 6j.
Lovely.
Positive.
Sorry, yes, I mustn't forget the plus sign. The sign comes too. Alright, 8ij minus 2ij gives us how many lots of ij?
6ij.
Lovely. 6ij. 6ij.
8j. Yeah.
14j plus...
No, 20.
Good, yeah. Plus 20j. Alright, and now substitute. So wherever we see...
6 times 2 times 7.
Oh, you guys are good.
20 times 7.
Very impressive, ladies and gentlemen. 6 times 2 is 12. 12 times 7 is 84. I think it's 84? Yes. Yep. And you can reach for your calculator at this stage. Now what's 7 times 20?
140.
140 plus 140.
224.
Good. Well done. Yes.
Can we use the ball?
So, wait, shh. Let her ask the question. Yeah, question? Which is minus?
Everything.
Yeah. Oh, that's an equals.
She's saying 84 take 140. Because there's a minus sign at the top.
Oh, because there's a minus sign here?
There has to be a minus sign somewhere.
Well, we've sort of got rid of that minus or accounted for it because it's 8 lots of ij minus 2 lots of ij. So the minus is being used already. So it becomes 8 minus 2, that is then 6. Yeah?
So wait, so it's always 6, it's always a plus at the top?
Yes, if there's no sign out here, it's a positive. If it was a minus 8, then it would be negative. But if there's no sign, you assume it's positive.
So it's always like add.
Yeah, there's always a little plus up there.
Okay.
224. Okay, so hopefully that'll give you some help when you go home, and if you struggled on homework last night, you have another night to do it because I won't be checking it today. However, today I want to give you a couple more examples, and then we're going to go on working through questions. So, question 3 looks like this. It says simplify these terms, and when we say simplify, we mean collect the like terms together. So we have to identify which are like, and then gather them all together. And these are more complicated, because who remembers the conditions that terms have to be there? You know what I'm asking? To meet.
Maybe powers?
Yes, good. So the powers have to be above the same variables, or above the same letters. Yeah, so please write that one down. I know it's a real nuisance.
Wait, in our notebooks?
No, go in your workbooks, because you'll need to do the work under this.
Yeah, can we do it?
Shirt is too warm.
Do you ever wear shorts?
Never at school. It looks too casual.
What happens if it's really, really hot?
Then I'll be really, really hot.
I always wear shorts.
Yeah, Mr.
Riley might look better in
These shorts are waist high.
Thank you. Can we stop talking about me in shorts?
Yes,
I wear them when I go to the beach like everybody else, but in school I wear trousers.
I always wear shorts.
I thought you'd wear shorts.
No matter what.
No, I'm a fan of jeggings personally.
Are you this here?
No, God no, they're foul.
You wear jeggings?
No, I don't.
Yes, it does.
Exactly.
Secretly, he does. At home.
Is this a new bit of work?
No, this example's from yesterday. Alright, so I assume you've copied that down because most of you are quite relaxed and talking now. So, when we collect like terms, we have to identify them first, and you're most welcome to use colours. If we see 5x cubed, it's a positive 5x cubed, what is similar to that?
3x cubed.
3x cubed. Now, can someone tell me why none of the others are similar? Because they all have x in them, so why aren't they similar?
Powers.
Valerie?
Because they have another letter with it and they also have different
Powers.
Yes. So nothing else has a power of 3 above it. Those are the only two like x's. What about the next one? Minus 6xy.
2xy.
2xy. Now, why isn't this one here? Why isn't that common? It's got an x and a y as well.
Because it's got the power of 2.
Good, it's got the power of 2, so it's not common. Alright. Sorry, I know I'm going quickly. Well done to those of you with highlighters keeping up. Alright. Let's collect the yellow ones together then. What?
5x to the power
Good.
plus 3x to the power.
Good, and what does that make?
8x power.
I was getting there. Wait, what? Can you work that out in a calculator though?
No, you can't. That's the thing. Algebra is largely done without the calculators.
All you gotta do is add the number.
But there's an x on here, what's that for? We have to figure out what the x is.
That is for when we solve for x. So we're not actually trying to find what number x is at the moment. We're just trying to simplify it, make it easier for us to work with. Alright, so the yellow ones are done. Now, if these are really long, what you guys can do is when you've collected the like terms, you can put a little line through them, just to remind yourself those ones are done. They're out the way, done with. What about the green ones?
Minus 6xy plus 2xy.
Good. So what's minus 6xy plus 2xy? Brianna? Good. Minus 4xy. Because minus 6 plus 2 is minus 4.
And then you add the plus 2x to the power of 2y.
Good. So there's nothing else we can do with that last one because it hasn't got a friend. It hasn't got anything in common with it.
Loner.
It just stays on its own.
Sounds like
2x squared y. Alright. You alright, Rogan? You copying? I know it might not make sense because you weren't here yesterday, but at least copy that way I can come over and explain it to you in a second. Alrighty. Can I scroll down?
Yeah. Were we supposed to copy that down?
That would have been good, yes.
Gosh, that would have been good.
Yes, you needed to copy it down. Alright. Now, copy this next one down. That is a 1.5. Are you having trouble seeing it? Can you see from the back?
Yeah.
Alright, it's 1.5 AB. Shall I make it bigger?
Wait, just saying, do we have to do columns 2 for the homework bit for 2?
Yes, you will do.
So we have to write that one down.
What? Yeah, the one I've just highlighted, do write it down. Huh?
I did. Yes, I have.
Sorry.
You underestimate.
You were complaining I was going too fast before.
You do.
Mr. Gutenberg, is this your class right now?
Not necessarily, no.
You should probably change it to that.
Yes, thank you. I know.
Okay.
Alright, so once again we look at the first term.
I want to do this.
It has, oh yeah, Demir wants to do it. We have a 1.5 AB. Is there another like
There is
term?
positive 10BA.
Good. Now, why, Mitchell, is 1.5 AB similar to 10BA?
Because they've still got the same letters, but just different numbers.
Yeah, good. Same letters, same powers, just in a different order. Alright. What about the minus 3b squared?
B2. No, it's B2.
No, the negative comes as well. And the last one?
By itself.
It's on its own. Alright, so how do we deal with the yellow ones? What does 1.5 AB plus 10 AB become? Brianna?
11.5 AB.
Good. Now the greens are difficult. A minus 3b squared.
Power of 2, take 1b to the power of 2.
Good.
Is that right?
Say it again.
Yeah, that's how we say it. Well done.
Minus 1,
minus 3b squared. So I'll write that over here. It becomes minus 3b squared minus b squared.
It'll be just minus 3.
So the b will be 1. The b will be 1.
Yeah? Minus 4. Good. Because if we start, imagine just doing it with numbers. Minus 3 minus 1 is you start at negative 3 and you go one more negative. So it becomes minus 4. The same happens when we're using b squared. If we have minus 3 lots of b squared and we take another lot away, then we have minus 4 lots of b squared.
I'm so confused.
Does it? Good. Alright, so you can almost treat them like numbers. You have a minus 3 and a minus 1. It becomes minus 3 minus 1 is minus 4. And like here, you have minus 3 minus 1. This is a little way up front. B squared just comes off to the right. So it's minus 4 b squared. Alright, and yes, plus minus, well, I haven't written this first. Minus 4b squared plus 12a because it has no friends. Careful. Alright, now I had to help a couple of people who were away yesterday. The rest of you, however, if you haven't, if homework didn't go well, you need to finish that question too, using the examples we did at the start of the lesson to help you. If it did go well, then fantastic. You can go on and do green 3 to 10. And the questions are relatively short, so you'll be able to get through them nice and quickly. Alright, go for it.